Hello and welcome. And good
Hi
morning, good
everyone,
afternoon, good evening. Hi, Michael. Nice to have you again
Alex,
on
good to see
our
you.
session. I'm looking forward to this one. So this is the second one we are doing together on Aura Free. So this is the 1 hour show basically where we go into Aura Free, pick a data set, and go a little bit into how quickly and easy it is for everybody to get started. But before we dive in, maybe um, tell us a little bit where you're from in chat, what you're doing at the moment. Is this your lunch break? Is this your early afternoon tea break?
Mhm.
Is this dinner, or are you watching us at 3
It's not
a.m.
tea.
because you you can't sleep?
Yeah, we had
if I
some of those folks that were watching like super early in the morning, like 2 a.m. or 3 a.m. because they're like night owls like
I was
I am.
totally, yeah.
But today probably should have some more folks from the US, right? So because
Yeah, this
this
is
is
this
the
is later,
afternoon,
exactly. We
the
changed the
later
format a
session.
little bit. Yeah, to every other week we do an earlier morning session European time, and one we do a later afternoon session um, uh, for us here in Europe. So that means different people should be more able to attend at least.
Yeah. So
Um,
let us know where you're from, what you're doing, and really looking forward to see some feedback from folks.
Exactly. While you type away, I'll give us a quick overview of what's going on and what the plan is for today. Um, so yeah, like I said, the plan is a little bit to do a quick recap of what is Neo4j Aura Free. I will do that in a second. Give you a short overview of what Aura Free delivers. Um, but the core of the session will be that we pick a data set and we pick a different one every time, or we try to pick a different one every time. Um, if you have a data set you think is interesting, you would like to explore, but maybe you don't know how, or you think it would be cool if Michael and I would do it, then give us a ping. You can type it in chat. You can send us a tweet. You can ping us on
Yeah, what's in
Discord.
yeah,
Um,
Discord? Okay.
there are various ways to reach out, and if you have something you would like to look at together with us, then let us know, and we're happy to do so in one of the next sessions. Um, Once we pick the data set, we will kind of explore a little bit in modeling land and see where we go, and what kind of questions we would like to ask. What would we like to know out of the data we have, and then obviously how would we model that, depending on the questions which we would like to solve. Um, and then we load and query and import the data and get it going, and then have some fun with it in Neo4j Aura. This is the plan for today. This is what we do. I'm looking forward to it. Um, Quickly, Aura Free. What is it, and what can you expect? So it's a completely free version of Neo4j Aura. So this means when you type in Neo4j Aura Free, go to a website in Twitch, you can use !Aura, and you get a link directly. I'll put it in chat in a second. Um, you get one instance for free for you, and it's for you, with you for forever basically. So that's maybe the major difference, so to speak, between Sandbox and Aura Free. Aura Free stays with you. The Aura Sandbox, Neo4j Sandbox closes down after a week. There's a little limitation in Aura Free, which is 50,000 nodes and 175,000 relationships. But I think for any experienced user, I guess this is probably not enough. But for a test run, for exploration phase, for giving a small fraction of a bigger chunk of data a whirl, and see if Neo4j or graphs are the right thing, this is completely fine. And you do get Neo4j Bloom on top of it as well, so you can use visualization with Bloom as well.
Which you can look at today as well. So we
And
can have a
we
look at it.
exactly cool. That's good. So we have a look at that. Yeah, today we look into Stack Overflow data. So Michael picked a Stack Overflow data set. I only know Stack Overflow, honestly. I don't know much more. Maybe Michael, you can give us a few more details about what to expect.
Yes. So perhaps I can share my screen. So we switch over to my screen.
Yep.
Cool. So every one of you who has been developing and looking for answers in any programming question or like libraries or how to do ABC, I think no one didn't come across Stack Overflow as such, right? So if anyone is programming in any language or question library, then you'll necessarily end up on Stack Overflow. So a lot of Neo4j questions are getting asked on Stack Overflow. So for instance, if you look here at the Neo4j tag, we see we had in total almost 21,000 questions asked about Neo4j, an all-time for Stack Overflow, which is really cool. So these are the news questions. So if you go to tags Neo4j or put in square brackets Neo4j into the search, then you see all the latest Neo4j, or can also look at active or bountied or unanswered questions. So if you want to help out a little bit with folks, then feel free to do that or ask your own questions as well. And so basically, question answer side. So if you look at the anatomy of a single Stack Overflow question, what does it look like? So first of all, we have the question, right? So someone asked a question, it has a title, it has an URL, it has upvotes, downvotes, it has someone posted it at a certain date. And there can be tags attached to a question. So for instance, if I use Cypher tag here, I see all the questions tag with Cypher. So you can have more than one tag on a question as well. And the other thing that you also, what are related tags? This is actually a question that we can also answer with Neo4j. And that's one that we want to look into as well. So what are the related tags to Cypher? Okay, what else do we have? We have answers. So different people provided answers to this question. They have also upvotes, downvotes. They can have also comments. And then there could be an accepted answer as well, right? So someone has, so multiple people have answered this question and one answer got accepted here as well. So in each of these answers has also an poster, right? So that's kind of the general anatomy of a question in Stack Overflow. So the answers don't have extra tags or they don't have an extra title. That's all coming from the main question, yeah, as such. Cool. By the way, if you have questions during the session, feel free to ask them. Alex can then point me to.
I'll have yeah, totally. Yeah.
Look at that. So how would we, what can we do with this? So first of all, we could ask different questions. For instance, what are top answers? What are like questions for a certain tag? What are frequent questions in a recent time frame? Who has been answering a lot of questions? So kind of quite straightforward things as such. Right? But then we can also do other interesting things, like for instance, looking at the tags and do multiple questions, repeatedly share tags. So for instance, does Cypher always come with a Neo4j tag? Or what other tags are coming with Cypher? We see here these related questions. Or could we figure out actually who could be really good for answering a certain question? So we could say, when someone answered questions in the past and look at the tags of questions that they are, and then look for new unanswered questions of these tasks. So we could recommend these questions to answer. Right? These could be, for instance, questions that we can look at as such. So as usual, we'll do a little bit of modeling and then we look at the data. All right. So we use Arrows again, our favorite graph modeling app. So if you haven't seen it before, Arrows.app gets you to the app. You can either store the data in your local storage of your browser or on Google Drive. And it's pretty easy to use and straightforward to use. So we can get going directly. So what did we have? We said we have a question, right? So we have a question which has been asked or posted by a person or a user. Let's call it user. Right. So this user posted the question. Right. So this is the wrong direction of our arrow, but that's not a problem because we can just click on reverse and it points in the other direction. Right. So the question also has some attributes. For instance, we can say the question has a title, which is a string. We can say it has an created date, which is a date time. We can have upvotes, for instance, which is an integer, right? So we have these kind of attributes here, and question would be our label, right? So we can also turn this into an question into a label, and then we can
Okay. Yeah.
Okay. And now we can use something else for the caption, for instance, a title of an cipher parameters or something like that would be our title. Right? So what else do we have? Our user can, of course, put other questions as well. Right? So we could say, okay, this user has also posted another question. Right? So we can have the label question here. Okay. And of course, sorry, I totally forgot the question also has like an body, so an actual text, which is a string, right? And a bunch of other attributes, as you'll see in a second.
So this means tags you would put in a separate node.
Exactly. So tags I would put in a separate node because they basically are external entities that multiple questions can share, as such, right? So something like a title or a date time and something was created on, but the body of the question is not shared, but something like text is.
This is something that's unique to the question. It stays with the question, and something that is more like,
exactly.
Yeah. Okay.
So, for instance, we can say our tag is Neo4j, and we have another tag that's let's say cipher. Yeah. If I only quick type cipher, right, and this gets also the tag here. Right. So, and then of course questions can have answers. Not every question has an answer, right? So there are, for instance, if a question just got asked, they most likely don't have an answer yet. But what we can do is now to say, okay, there are a bunch of answers for a question. For instance, use them as our answer, cipher parameter system, and we can call this an answer. Give this an answer label here, right? And of course, this answers the question, and we just want to point the arrow in the other direction, right? So this answers our question.
Okay.
And of course, someone has to have written the answer as well, right? So we can just add a note here for another user. Let's say another user. We should probably turn this into an, so this is John and this is a user, right?
Yeah.
And this is, for instance, Helena answered this question by writing her answer. So posted or wrote or whatever we want to call this. Right? So, and this is kind of the basic structure. Of course, you can add comments and other things as well, but this is kind of what we want to look at.
And if an answer is picked as the one, should that be a property?
So there are several possibilities. So there could be something like accepted answer. So we could say an answer could have an additional label. It's called accepted. This is one option. The other option could be that we put a property on the answer that says accepted, which is a Boolean, true or false, right?
Yeah.
third option would be that there's actually a backwards relationship, only one per question, that's called accepted answer.
Ah, okay.
So, and actually it depends a little bit. I'm not sure why the rendering is a little bit broken here. Let me seems to have not updated it. It's like an older version of Arrow, so perhaps my browser cached this too aggressively. Let's see. So there could be one that's an accepted answer, basically, right? So that's we have three options here, and depending on your questions, depending on your needs, each of them could be possible, right? So the Boolean property I would probably not use. The accepted label gives us a quick way of finding accepted answers because the labels are very easy for the database to basically find out. And the accepted answers is useful when you want to go, especially from questions, to the single accepted answer, because there should only be one accepted answer.
Yep. Yep.
Right. So other attributes that we have, for instance, the user has, of course, stuff like screen name, which is a string, and bio, and things like that. And the answer itself has, of course, something like a text, which is a string, and then, for instance, also upload, which is an int. Right? Uploads and downloads and favorites and so on. So this is basically our basic data model that we can look at. Right? The interesting bit here is, of course, that these tags have not just one question that they're connected to. So we would probably say tagged. So flip around the relationship direction. So, or actually, I think it would go from the question to the tag. So this question is tagged with Cypher, and it's tagged with Neo4j. And you can have as many tags here as you want. And then, of course, other questions can also be tagged with one or more of those, or zero or more of these tags as well, right? So we could also then say, okay, this question over here is not tagged with Cypher, but only with Neo4j, for instance, or with JavaScript or whatever you want to tag, right? So, and it's quite nice. Of course, we don't really want to go and enter all the data ourselves, right? So we want to find a way of automating the import. So there are two ways of doing that. So one is a quick way of getting access to a subset of the data, which is what we will look into today. The other way is taking the overflow dump published, I think, monthly overflow to the Internet Archive. And so you basically can every month you can get an overflow dump with all the answers, all the people, all the votes, all the comments, and everything in one gigantic file as such, which is then like has lots of, you can process them and import them into Neo4j. There's actually importing 10 million Stackoverflow question. So there's a blog post from a while ago where we've done this, and we've done it several times ever since. I also have a GitHub repository with a converter that takes the format from Stack Overflow, turns it into CSV, and then can import the whole file basically with the batch importer, with the dump, with the bulk importer of Neo4j. Right, so it's quite a lot of data, and so it's a little bit too much
too big.
Aura-free.
Yeah.
Aura-free. But if you take one of the Aura Pro instances, you could import it into the database then as well. So, but what we want to look at today is basically an REST API that Stack Overflow has, and so you can basically get the questions API endpoint, and then say, I want to get 100 questions in this sort order with this tag Neo4j from Stack Overflow, and then gets you this information.
Okay.
So if you look at this, in the items list for each question, you have the text of the question, the person who posted the question, all these counts that I mentioned, comment count, delete count, is answered, flag, new count, favorite count, downvote, upvotes, answers, scores, and so on, activity dates, share link, and the body, basically. Right, so each question has basically the same, and then some question have also answers. Let's see. If you find one with answers. This one here. This one has also answers, and then for each answer, you have the comments on the answer, the body of the answer, the person who posted the answer, and then that's it, basically, on all the other details, right? So it's a really nice structure in the JSON that we can take and turn into a graph. And fortunately, Aura free. By the way, if you haven't done it yet, you can basically go to Aura and say, you log in and you say, I create a database, I create an Aura free database and call it Stackoverflow. Should have set this at the beginning. And then you say, create free database. You need to copy the password somewhere and then say, I have saved this password. Oops. I have saved this password. And then it creates your database. But it takes a few minutes, so I have pre-created that and so that we can get going already. So we have an empty Neo4j database here, so there's nothing there. And we can now import this data from the REST endpoint to JSON into Neo4j. And what we're going to use is a user-defined function called, or user-defined procedure called epoch load JSON. And that can access REST URLs or any kind of URL that returns JSON. And then we can get the information into Neo4j. So as an example, by the way, we can probably post this. So basically, if you just Google epoch load JSON Stack Overflow, then it gets you directly to the page here.
Yeah. Okay.
Right. So it's pretty straightforward to find. And then there's here on the right side the import from Stackoverflow, and then here is the page that I'm using. Yes, right.
Okay.
Okay, cool. And here's an example. We can copy this to the clipboard and use it a little bit by looking at it. So what we do here is, this is the URL that I just showed you, right? So 100 questions tagged with Neo4j. So if you want to, if you're interested in another tag, let's say a React or GraphQL or Kubernetes or so, feel free to change this tag to whatever you want. And this is our URL. And we pass this to epoch load JSON. And what epoch load JSON returns, actually, we can actually look at this. Let me make it a little bit smaller so we see only like, let's say, three questions instead of 100. And if we just look at what does this value look like that we're getting back. And if you look at this, so it's basically just in Neo4j's structure. So this is kind of maps with keys and values, and these can have lists, and the lists can have, again, maps and keys and values, and literal values and strings and all this stuff. So it's basically exactly the same as you've seen here in the browser as well.
Mm-hmm.
So, and this is what we can work with, right? So we can now take, for instance, this owner field here and turn it into a user in our database. And we can take the title of the question. Somewhere it says title. There's title answers. Somewhere's title. Here, title, and turn this into our title for our question. And you can take the create date and or creation timestamp, which is a numeric timestamp here, and turn it into our creation date, right? So we basically take these things out of this tree structure in the JSON and turn it into our graph structure. Right? So an example of this is, So we get our value, and then value has items, as we've seen here, right? So value has items. And for each item, we want to do something. For instance, we say here, we unwind each of these items. So this list here, items is a list, is turned into rows. So each of these questions, which is in the items, turns into a row. And then we just return the item title, the item owner, so the person, with all their detail, the creation date, and the other keys of this item. So what are the other keys of this map structure here for the first few items, right? We just take this list, turn it into rows, from a list into rows, and then for each row, we just select a bunch of stuff that we are interested in. So if you run this,
I guess you need to up the number again to 100.
For this example, it's okay.
Yeah, okay.
We'll do it later. Yeah. So it's only 3 that we get back, right? So good point. Yep. Let's pay attention. So we only get 3 records back because we said you want to have only 3. Yeah.
But yeah, you limit it to 5, so it doesn't much. Yeah.
So we have our title, so which is kind of the questions that you could see here in the Stackoverflow UI as well. So it's really live data, so you can pull live data from Stackoverflow, which is really cool. The creation date is this epoch timestamp, 6 seconds since 1970. And then that's the epoch timestamp. Alex, if you haven't heard that, that is
interesting way of measuring time.
How Linux and Unix timestamps started all January 1st. And that's why the reason something wrong there, you get actually January 1st, 1970 as the date oftentimes.
I see. Okay.
Epoch from 0, right? Actually, you can test it in Neo4j as well. You can say return date time of epoch seconds 0. And it returns January 1st, 1970 at midnight. So that's the first entry in this time frame, basically. Exactly, and then exactly that's the beginning of time. I was not even born then. It was 5 more years until I was born. And then the other thing that you get is the owner, and you see that the owner is again a nested structure. So, for instance, if you are only interested in certain aspects of the owner, we can also just extract the information that we need or want. Right? And then all the other keys we have for this question, we have the owner, we have comment count, the link, last activity date, and so on. Upvotes, downvotes, question IDs. Question ID is actually quite important because it's our unique key for the question. Should probably have added this to our model. So we should probably say our question has an ID, as it's a string. Because I'm not sure if it's alphanumeric or numeric only. I think it might be numeric only, but to be honest, if so, you can also turn it into a string. And a bunch of other things, right? So that you've already seen in the UI or in the JSON already. So, and if you want to access any of
because in the past, when in these sessions we always used CSV import. So having done this, it looks very much now similar to what we did previously with the CSV import. So we basically we take away the JSON a little bit and make it so that these individual fields can become nodes, like you said before, in a similar fashion to the CSV import we used to do before.
Exactly. So we basically deconstruct the JSON a little bit and flatten it out into individual rows. So for instance, imagine this owner field, we don't want to have the JSON here, but we want to have the other details. So we could say, let's say we get the user ID and the display name. So we would say item owner user ID and item.owner.display name, right? So, and if I run this, and then we could also, for instance, imagine we were also interested in the, let's say, into the share link of the question, right? So we could say item.share link. And if we rerun this, then we see that it's basically flattened out completely
okay.
like a JSON would be, right? So then it's completely flat. And that's something that you can also do then, right? So that's, so, and because it's live data, we can basically take the data live from Stackoverflow and turn it into our graph. And now it's basically the same as we've done before. We basically create nodes and relationships based on our model, right? So we would create a node for the question where we use the question ID and the question title. We would create a second node for the user where we use the item owner user ID as the ID and the item owner display name as their name, and so on. Right. So to just do this small example here, what we can do is we can basically take these and say we use merge here. So that means even if we run this twice, it will not create the data twice. So it will only create the data once. Right. So we create a question, like we said. And we want to have the ID is the item.question ID. And then after we created the question, we can then set, for instance, q.title equals item.title. So we set the question title. I'll just leave off the other properties for now. And then we do the same for the user who posted this question. So let's say the owner, which is the user. And their ID is not the question ID, of course, but it's item.owner.user ID. So we basically reach into the structure and pull out the user ID and use this as our ID for the user. And last thing we do is we create a relationship. So this user posted this question.
And then we could also add, like we did with the question, we could add a instead of just having user IDs, we can also have a username.
Good point. Yes, exactly. So we would say o.name, owner.name is the item.owner.display name. Right. So we can choose our own property names. You don't need to use the ones that Stackoverflow uses. We can use our own. Right. So then we say this user posted this question. So we create a question for each row. And then a user, if it doesn't exist yet, right? So because the same user could have posted already previous questions that user's node might already exist. And then we just state the fact that this user posted also this question. Right? And then what we can do in the end, we can just return our newly created nodes and relationships. Q, O, and let's call this relationship R. And then we can even remove our limit. And if I run this and I have not misspelled anything, which I hope I didn't, then we should get three
sets. Yeah.
3 sets. Where you can see the blue ones are the users, the orange ones are the questions, and the relationships in between. Right? So now if we change our page size, as you said, from 3 to 100 again, can run it, and then
now you get that should be fine.
We get 100, right?
Yeah.
So which is we can actually make.
And then now we see that a couple of users have asked more questions than just one.
Exactly, right? So that's really nice. Already something like a structure to see, right? So there's obviously already certain users had, for instance, they started out using Neo4j and they had a bunch of questions. Right?
Yeah, so this one right there.
Even one person here who was very in the last 100 questions, they already asked how much is it? Seven.
Yeah.
7 questions.
Yeah.
Pretty prolific asker of questions. Right? So, and now we can continue with our data structure, right? So now we can say, okay, each of these questions also has tags, as we've seen in our API here, right? So we could now do the same here and say, okay, we also want to, for each our question, we want to take the tags and create entries for each tag, right? So then we say, for instance, unbind item.tags, as tag. So this is kind of taking this list of tags and turning each of them into a row again. So there are two options actually, unwind and for each. Let's look at unwind first, and then we can look at for each as well. Unwind item text as tag. So each tag is basically just a string, right? So we don't need to do any dot things anymore. So it's just here. And now we can basically say we merge our tag with the name, so the one that we got from the JSON. And then we also say this question is tagged with this tag, right? So we return all, and then we're good. So we create a tag here, and then connect the question to this tag. Okay. So the other ones we could leave in there or change things, but because it's all these operations are idempotent, so they would just not change anything if the data is already there. We can also just leave them in there. It's up to us. So it's, you can incrementally build up something like this as well. Oops. And it complains there's a with required between merge and unwind. So it says here and in this, for this unwind, it wants in with. So we can just say with star. So sometimes Cypher has certain requirements in the query, and then it just completely works.
Because you already have an unwind at the top, you need this with?
No, it's just because merge is a write operation, and then unwind starts a new block or a new query pod.
Okay.
And so with is just something like a boundary between query pods. It should be automatic, but in this particular case, it doesn't want it. So now it creates all the data again, and then you'll see.
Now we create all the tags.
Now we create all the tags and all the other stuff again. And something that actually happens here is now, because you have already all this data in the database, so we have 184 questions and 100 relationships. It actually takes longer than before, right? So because the database was empty before, but now it actually has to check for each question and each user and each tag, does this one already exist? So actually, oops, that's an interesting one. Okay, so it complained that it needs more memory that it has available. So our Aura database here should actually now see how many nodes and relationships it also has.
That's interesting.
It
takes sometimes a little bit longer
to update. So it has, I think, a gigabyte of total memory. So it shares this between like system stuff, on heap things about this. But I think if you're lucky, you can probably avoid this by just looking at the indexes first. So let's see. I'll try this first. I don't want to change it for now. So let me just create and constraint. And what I wanted to say actually is to say, basically, because it has to check each of these things, does the question already exist? Does the user already exist? Does the tag already exist? It takes longer the more data is already in the database.
Yeah.
So we just create three constraints. One is on question. Assert q.id is unique, so which is the unique constraint on question. Okay, then we do the same for our user. Right, and in tag, we didn't call it ID, we called it name. So if you have multiple keys that form or multiple properties in a unique key, then you there's also a syntax for that, which is called node key. So if you're interested in these kind of things, there's this Cypher pod, which has all these syntax things in there. And so for instance, create constraint. You see this syntax here as such. And so if you hit software or something like this, then find it in the ref code. It's quite useful. So we created our 3 constraints. And if I now run schema, the schema command, schema command, it shows me our constraints basically that have been created together with some basic system constraints as well. Okay, so now if I rerun this, let's see if the memory is still not enough or if it actually finishes this quick count. There's one other thing that we can do actually, which is we can make these set operations also conditional. So that means if the question already exists, we don't need to set the title again. If the user already exists, we don't set the name again, and so on. Right? So there's the merge operation has this on create clause. So it would only set the title when it's newly created, or only set the name when it's needed. Right? So it still doesn't like us. So we'll probably take a few, let's say half of them. Let's just take 50. Okay, created our 50, and then we can do the other ones as well. So if you look at this now, oops. If you look at this now, we see our questions, and then we also see tags here, right? So we see, for instance, the Neo4j tag, which is pretty connected, the Cypher tag, which is pretty connected. We see the kind of Groovy tags, we see GraphQL tags, GrandStack, and so on, Python. Right? So this helps us now to answer some of our questions already, right? So what I'm gonna do is we can, now we have a page size of 50, so this was the 51st questions. And now we can say, for instance, page equals 1 and page equals 2. So the second page, we can just run one page after another, basically, to import more data. Right? So you see, kind of this adds more data here on the other side. So you can also say.
No, I guess because you added this on create, probably that helped a lot. It skips.
But I ran it once, so it's still doing the merge there. But it's so you see it's adding more and more data here.
Yeah.
So you can also automate this a little bit more, but not sure if you have the time today. But perhaps one of the next times you can look into APOC and what we can do with batched data creation updates. And things like
that's a good idea.
So now we created like 4 pages, 1, 2, 3. Let's do another one. Let's create 4 pages of data. By the way, you also see it if you quick click to the table on the table view here, how many labels, nodes, properties, and relationships have been created. So you also see how much data was created for each run of the statements. Right. So we now have 500 nodes and 720 relationships, both posted and tagged relationships. Right? So we could, for instance, also say, let's look at a tag, like, for instance, the Python tag. And then we can say, please expand this Python tag. So we would see all questions tagged with Python, for instance. Right? And then we could say, okay, if you pick one of these questions, what else have they been tagged with? Probably Neo4j, right? Because we've been looking for the Neo4j tag.
Yeah.
And Cypher as well.
And Cypher as well. Okay. Yeah. Makes sense.
So, which now allows us to answer one of our questions, kind of what are related tags to another tag, right? So we, for instance, we said we have a tag. So we find our first tag, which is our, here we had the Cypher tag, right? If I click on the Cypher tag, it says down here, what are related tags, right? So let's see if we can compute something similar in our graph database as well. So here we found our tag, which is called Cypher, right? and you can just return it just to see that this works. Okay, there's our single lonely ciphertext. And then we want to do is we basically want to go from the ciphertext to questions, and then look at each of those questions. What are the other tags that have been used with these questions, right? And then sort them by frequency, how frequently they have been used. Okay, so we basically spell out this pattern that are not now just clicked in the UI. We can also spell this out basically, where we can say, okay, this cipher tag has questions. So we are not really interested in the questions. We just say that there's a question in there, right? So the question itself is not interesting for us. It's only interesting for us basically how many questions were there. Okay. So, and then we say this is being tagged. This question has been tagged with cipher. So we could leave off the relationship type because we have to tag here, but it's just good practice to add it there because it's more expressive and it's also for larger data it gets faster by adding relationship types as well. And then we have two. So it's again tag, right? So we have basically what's the other tags. For each cipher tag, you find a question, and then what else is attached to this question, basically as tag. So there could be 1, 2, 3, 4 other tags, etc. Right? So, and what you're now interested in is kind of what are the names of the tags and how frequently did they occur. And this is where we use aggregations. So the simplest way of doing this is just to return the name of T2, of course, right? And how often did it show up in our query? So count star, right? And then we just say order by count star descending. And then let's look at the top, let's say 5 or 10 related tags to cipher, right? So in our 4 pages of data, so the last 200 questions, we should now see.
Do you need to make sure that T1 is not T2?
That's something that Cypher does automatically. So basically to avoid circular loops, right? So otherwise you can, if you have larger patterns, you couldn't get into loops. It says every relationship in such a pattern only occurs once. So of course the relationship to Cypher is already used up on the left side. Basically, it can't come in on the right side here.
Okay.
Again, right? So each relationship is unique in a pattern, to say so, right? So if it's already been used somewhere in a pattern, even for larger pattern, that's true, right? So if it's been used already somewhere in a pattern, then it can't show up again as such. In a single pattern, we can actually look at this in a second. Let's just quickly look at the results. So it says Neo4j, which is obvious, right? So there's Neo4j epoch graph databases, Java, graph, Python, parallel processing relationship. And if you look at our Neo4j, Java, epoch, Python. So this looks at more data, not just at the last 200 questions, but you see we're getting these similar results here as well. Right, so we can do basically the same as the Stackoverflow UI does. To your question, Alex, is if we split this up into 2 matches. So if you also say match first from the tag to the question and then from the question again to tag 2, then we have 2 separate matches. So that means this relationship here to Cypher can show up here again because these are independent matches, to say so, right? It's only valid in a single pattern that they can't occur twice. So here now, actually, the Cypher pattern itself, the Cypher tag itself should show up now on top. Right? And
yeah,
you see
obviously, yeah.
Right? But if you put this into one pattern, then Cypher itself takes care of that as well.
Oh, that's good.
So
yeah, it's gone. Yeah.
All data here.
Yeah.
Cool. And this was the first question that we wanted to answer with the data in our database. And then the second question that we wanted to answer is kind of this kind of recommendation engine where we say, hey, can we find people that have answered questions with certain tags frequently, and can we find unanswered questions with these tags and recommend them to these people, basically, right? Which is a little bit more involved for two reasons. So we need a little bit more data in our database because we only have questions.
We only have questions, yes.
And the users that ask this question in the text, but we don't have the answers yet here, right? And we also don't have the users who posted these answers as such. Right?
And we don't have the upvotes or the accepted or something like that. Yeah. So we don't know. Yeah. If the answers are good, I mean, there could be like 5 answers to a question, but 4 of them are not really good and only 1 is good. So the one that is good should be, yeah.
So we can either look at the upvotes, because sometimes in Stackoverflow you have also something that someone accepted an answer, but then someone else gave a different answer later on, and which was actually better because it's probably more recent or more up to date or something like that. But then the original person who asked the question didn't go back, and I think I'm not even sure if you can change it. What you accept as an answer. So it's basically, a previous answer was accepted, but a newer answer might be better. And so looking up at upvotes as well is also sensible in that regard. So because we don't have too much time left, we can just steal the statement to import all the data.
Now you. Oh yeah, here we go. You were muted for a second. Yeah, you're back.
Okay. Can you still hear me? I think my...
Yes, now I can hear you. Yep. Now we can hear you.
Okay, so here we have actually all in one, right? So we have basically our oh, this is not what I wanted to do. This here. So we have our import that we just looked at. We get our question, we set the title, share link, favorite count, we set the tags. So this one here uses for each and not unwind. So for each, just basically in one line what you do with unwind in multiple lines. And then for each of the answers, it basically creates the answer to this question, and then also connects the answerer, the person who sent the answer, and then we connect the answer to the answerer, and then we have this, and then we also put in these who asked this question. So the model is a little bit different. So what I quickly do is I'll just quickly clean out the database. Let's see if this works. Because otherwise I would have to fiddle around with all the things.
Yep.
And now we can just steal our statement here from the docs. And as I said, we create our questions, we connect the tags, we connect the answers, and the answerers and the user who asked the question as well. And to not get out of memory, I'll just put in a 50 and page 1 here. Okay, let's see what happens. Running this. So now you see here it also pops up answers.
Answer here is there. Yeah.
Right? And also provided and answers and asked. And so the other relationship types are here as well.
That was fast.
So let me just do this for the next 2 pages. Or 3 pages. Number 2. Number 3. And number 4. So we now have 600 nodes and 1,000 relationships in here, which should be good enough for what we need.
Yeah.
And now we can say, okay, what are we interested in? We are interested in questions. Which has answers, right? And the answer was provided by a person, which is our user, our answerer, right? So this is step one that we are interested in. So what are the questions that have been answered by user?
Mm-hmm.
And the other thing that we're interested in is which tags do these questions have as well, right? So this would give us kind of, for each tag, now we could say, who are the most common users that answer this tag, right? So we could say now return t.tag.
Why do you separate
then,
these two with a comma instead of doing two times match? Is this
because
a difference?
I could do two matches. Yeah, both is possible. So
Okay.
I just want to do it into one pattern. And we can also do two matches actually.
So this is basically the same.
Yeah.
Okay.
Yeah. So, and then we just say we return the tag name and the user name. And we again count them and say count. Let's see, order by. So this would give us only the globals. So kind of across all tags, basically, who were the users that answered them most frequently. So it might be the top answerers across all the tags, basically. Right?
Mm-hmm.
So for the time being, this should be good enough. So we could also do this. Oops. Is it called display name? Sorry, in this model. Display. So we had in our model here for the Neo4j tag and the Cypher tag for affiliate answered or provided the most answers, and then Tomasz, Jose, Florent, again Tomasz, and David. Right. So now we could say, okay, find me questions that don't have, and so we just do it like this, and then we can say, find me questions that don't have an answer. So we say, find me questions. Actually, let's start with those questions. Where not exists. And here we can use one of the new features, which is called an access clause, and say there's no answers. Sorry, my old Mac is finally put overloaded.
So you're basically excluding a certain pattern here.
Exactly. I am excluding this pattern. So this answer pattern should not exist. So actually, let's start with this. But what we're interested in is basically our start question that we want to get people for, right? So we don't have answers here, but we have tags here, right? So we have tags, and then for these tags we find questions, more questions. It's not our Q0, that's our other question. For these tags, and find for these tags who has been answering those, right?
Yep.
And then we basically can say, okay, for our Q0, basically, we can, or for these tags from this Q0, let's see, we can probably even this. We only want to do it for the first 5 questions or something like that, right? For the top question or latest question, then something like that. So we just get it for the first few questions, and then we basically get back who are the people who are most likely to answer our first questions. So we can also return q0.title, tag.name, and display. So, and if you run this, then we see for this question, for this tag, X, this person would be most suitable. Right?
Mm-hmm.
And of course, you want to aggregate this over all the tags. We can also just say, give me all the tags into a list. And it counts basically across all tags as such, right? So it doesn't do it per Neo4j and cipher tag, but it would do the sum of those, right? So the count it could happens in across all of them. And so we say, oops, I don't want to have each tag every time in our list, only once. So you see, okay, these folks have been answering across Cypher and Neo4j 82 times, or to March 37 times. Right? So, and then you see for this question, these folks would be most likely to answer this one, right? And so on. Or for the next question, with parallel processing, actually Tomasz has been most
active.
Frequent.
Yeah, okay.
And then we have actually already a recommendation for folks to answer. Yeah. And you see with a few lines of Cypher where the first bit only determines kind of what do we want to answer, and then the second bit determines with 2 patterns basically determines who is most likely to give us a good answer on those tags. And that's something you could apply into any
exactly. I mean, we can develop this. We could develop this further. We could say, okay, let's add in upvotes to that recommendation.
Exactly.
Let's add in accepted answer to that thing. So it's
exactly. So then we would also not just count them, but we would sum, for instance, the upvotes across these questions, right? Or sum the upvotes and multiply it with a weight based on if this answer was accepted or not accepted, for instance. So we can have a more complex measure for our score. So this count is basically our score. And if you wanted to do a more, realistic measure for the score, then we would include these other things like upvotes and accepted answers. Yeah, and that
cool.
kind of takes us to the end of our session today. I hope this was helpful and interesting, and you enjoyed it. I definitely do, because I really like this Stackoverflow dataset. And
that's a cool dataset, yeah.
From that perspective,
Perfect.
Thanks a lot for watching.
Exactly. Thank you, Michael, for showing us through the queries and explaining to us how it's done. Yeah, maybe we continue with this a little bit further and add a little bit more flavor to it next time, and then could potentially even look at it in Bloom. But there was no time today for that.
Yeah. So there was one question from Mariano. Mariano, if you want to look into that, look at the Cypher ref card. There's the syntax for creating indexes and constraints.
Exactly.
So
the ref card is a super helpful thing for anything. I mean, you can find every query that is there with every term explain it, and even a link to the full list in the documentation where you can read up on it, how to use it, what best practice, and an example. So it's really a good piece.
Exactly. Cool.
All right. Well, with that, I think we close for today. And see you around next time. Hope you enjoy this session. And if you have a data set you would like us to explore, please let us know.
Let us know.
Thank you, Michael.
Okay, cool. Take care, everyone.
Bye.
Bye-bye.